Good evening, students. We're having acids, bases, and salts today. Chemistry, acids, bases, and salts. Acids, bases, and salts. Okay. We'll start with acids. Majorly, in chemistry generally, chemical substances are either acids, they are either acidic, basic, or neutral. Okay, they are either acidic, basic, or neutral. A substance might not be an acid, but it's acidic. It is acidic when it possesses what? It is acidic when it possesses acidic properties. It is acidic when it possesses acidic properties. All right. We're going to do acids, and then we're going to talk about the properties of an acid, both chemical and physical. All right. The properties of what? Of acids, both chemical and physical. And then we're going to talk about bases and their properties. Okay. Salts are meant to be neutral. All right. So a substance is said to be acidic when it possesses what? Acidic properties. It might not really be an acid, but when it possesses acidic properties, it is what? It is an acid. Do you understand? So that is how it is, right? So we're going to what? Acid. Okay, acid. Now, the basic definition of acid in our basic chemistry, all right? The basic definition of acid is that an acid is a substance that dissolves in water to produce hydrogen ion as the only positive ion. An acid is a substance that dissolves in water to produce hydrogen ion as the only positive ion. Now, this is what it states. Even when I was in, when I just got into science class in my school, I believed in those days that is how acid is being defined, and I defined it. I just crammed it like that, just put it in my head. But I didn't really understand what it means, what that definition truly means. An acid is a substance that dissolves in water to produce hydrogen ion as the only positive ion. I will explain that, what it means literally. All right, so just go with me. All right, acids. Now, generally, all compounds, polar compounds. A polar compound is a compound that can what? That has both positive parts and a negative part. All right, we have a positive ion and a negative ion. All right, so let's pick, for example, a compound like sodium chloride. Sodium chloride. A compound like sodium chloride. All right. Now, sodium chloride consists of two ions that comes together to form, and that is what? Na plus and what? Cl minus. Okay. Of course, we know sodium. Sodium has an electronic configuration of 281. That is, it has 11 electrons. It has an atomic number of 11. So it has 11 electrons. All right. 2 electrons goes to the first shell or first orbit. 8 electrons go to the second shell or second orbit, and the remaining 1 electron move to the third shell in this manner. 2, 8, 1. All right. Now, when you want to attain an octet structure, according to the octet rule, when you want to attain an octet structure, it will either gain 1, or it will either lose 1 or gain 7. But like I always tell my students, it always goes for the lower number. Why? Because whether you are gaining electron, whether an atom is gaining electron or an atom is losing electron, it is consuming energy. There is energy required. Okay, there is energy required for what? For an atom to either lose electron or gain electron. So when it wants to gain electron, it will consume an energy. There's an amount of energy that will be required, okay, that will be consumed when it gains electron. There is also an amount of energy that it will consume when it loses electron. So whether it gains electron or loses electron, energy is consumed. So, and that is why for an electron to be for this electron condition to be complete, the outermost shell must have the maximum number of electrons that it can contain. Like here now, the outermost shell or the valence shell. The outermost shell is also called the valence shell. Okay, the outermost shell in this case is the third shell, and it can take what? 8 electrons. It can take 8 electrons. So the aim of this one atom and every other atom, okay, is to what? Is to attain a complete electronic structure where the outermost shell contains the maximum number of electrons that it can what? That it can contain. And if you look at this now, sodium, the outermost shell contains 1 when when 8 can be collected there. So what does it do? Is that it gains 7 here, all right, and lose this what? This shell. Are you getting it? Or I mean, is that it gains 7 and this shell will be complete, or it loses this one and loses this shell? Okay, so but it rather goes for the lower number because why? The amount of energy required to what? To lose 1 electron is what? Is much smaller. When you compare it to what? To the amount of energy to what? To gain 7 electrons. So that's why it will go for what? For losing 1. So when sodium loses 1, it is what? It becomes what? Na plus. Alright? Because when you lose 1 electron, okay, the number of electrons reduces to 10. That's minus 10 because electron is negatively charged. Alright? Minus 10. Then the number of protons is T11. So minus 10 plus 11 is what? Plus 1. So that's why it has an auxiliary state of plus 1. The same way this happens when what? When in the case of chlorine is what? 17. And it has 17 electrons. So 17 electrons, 2, 8, 7. 2, 8, 7. 2, 8, 7. Alright? So this one now, this chlorine, 2, 8, 7. The outermost shell, the valence shell, has about 7 electrons. So it either loses this 7 to lose this shell, or it gains 1 to be complete. So it goes for the lower number again, gaining 1 because the energy required for what? For 1 electron is what? It's much smaller than the energy required for what? For 7 electrons. So that is why it was NaCl minus. So when you combine both of them, of course, alright, when you combine both of them, you have what? NaCl. Okay? Now, NaCl is what? Is a salt. Is the salt. Is the crystal. We're going to define salt and we're going to tell you how NaCl is what? Is a salt. Okay? But for now, just now is a compound. Alright? It's a compound that is present in form of solid, like crystals. Alright? The one we use to cook. Alright? That is what? The sodium chloride, NaCl. Now, when you dissolve sodium chloride in water, what happens is that the bonds that are holding sodium ion and chloride ion together, as well as the molecules of sodium chloride, making them to what? To be together, and making them to what? To form solid. Okay, making the molecules join together, holding the molecules together, and also holding the ions together. That bond is called electrovalent bond, and it is a very strong bond, and that is why sodium ion and chloride ion are together and much held together. Okay, the bond holds sodium ion and chloride ion together, and also holds what? Little molecules of sodium chloride, okay, together to form the what? The solid crystal. Do you understand? All right. So that is what happens. All right. But when you put this sodium chloride, the crystal of sodium chloride now, you put it in a container. You put it in a container. Already, water molecule, you put it in a container and you pour water into it. Okay. You pour water into it. Already, water molecules contain what? Hydrogen ion and hydroxide ion. Are you following? Already, water molecule contains what? Hydrogen ion and hydroxide ion. Okay. Now, when you now put the water molecules inside this, and it now mixes what? With the sodium chloride. What happens is that what? The bond, there is a kind of conventional weakening of the what? Of the bonds that holds the sodium ion together with the chloride ion. Okay? So they weaken these water molecules, overshadow these bonds and weaken them. So it gets to a point they become too weak to hold the what? The molecules together and also the what? The ions together. Are you getting it? All right. So because of that, this what? Sodium chloride compound will now start disassociating. The molecules, the ions will now start what? Separating from what? From each other, from one another. All right. So because of the fact that the water molecules, it kind of conventionally weakens these bonds here, the bonds here, there is a separation, there's a disassociation. In chemistry, we call it dissociation. Okay. There's a kind of opposite of association, disassociation. Okay. All right, we call it dissociation. It dissociates to form sodium ion plus what? Chloride ion. So in this what container now, we now have what? Numerous what? Positively charged sodium ion and numerous what? Negatively charged what? Chloride ion. Moving randomly in the solution. Together with what? The already hydrogen ion and hydroxide ion that we are already part of the what? Part of the solution. So we have two positive ions there. Two different kinds of positive ions there. Hydrogen ion and sodium ion. Okay? And we also have two different kinds of what? Negative ion. Chloride ion and what? And hydroxide ion. Am I communicating? This is what happens. Any substance at all that is polar in nature, when you dissolve them in water, what happens? The bonds weakens and what? And they dissociate. If they cannot dissociate, if the water molecule is not able if the water molecules is not able to weaken the bond enough to make them separate, that substance will not dissolve in water. If you put any substance, any solid in water, and that solid does not dissolve, just know that the water molecule is not able to weaken these bonds. And so what happens? They did not dissociate. Okay, when they don't dissociate, they will still remain solid in solid form. So you'll be able to still see them inside the liquid. But when they do dissociate, when they dissociate like that, they will disintegrate because ions generally are too small to be seen by the naked eye. So when they dissociate, all of them they separate, they break down, okay, inside the liquid. You're not able to see them singly. Though if they come together, you're able to see them. But when they are separated, you're not able to see them singly. So it appears as if the solid had disappeared into the what? Into the liquid. But no, it didn't disappear. Okay, they only disassociate. Now we now have what? Ions singly. So they are inside what? Inside the solution like that. Do you understand? So when a compound like what? Like sodium chloride, when a compound like sodium chloride dissolves in water, all right? When a compound like sodium chloride dissolves in water, if you look at the ions there, the positively charged ion, you find two different kinds of positive charged ion, and that is what? Sodium ion and what? And chloride ion. Am I communicating? You find sodium ion and hydrogen ion. When you what? When they dissociate, okay, after the sodium chloride dissolves, what kind of positive ion that we produce? We have a sodium ion and hydrogen ion. Any other kind of solution that you dissolve in water, any other kind of solution that you dissolve in water, any kind of solution that you dissolve, any kind of salt or solid that you dissolve in water, it will produce different kinds of ions. Okay, the positively charged ion that you find there will not be only hydrogen. Even when you dissolve what? Calcium, let me say calcium sulfate, CSO4, calcium tetraoxosulfate 6. If you dissolve it in water, all right, what happens is that what? Remember, water still has what? H plus and OH minus. All right. Now, when this dissociates, when you dissolve in water, of course, water will overshadow the bond and what? And the bond will be too weak to what? To hold them together. So it's not each calcium sulfate molecule will dissociate to what? Ca2 plus and what? And SO4 2 minus. So we have numerous Ca2 plus ion. We have what? Numerous SO4 2 minus. We have numerous what? Hydrogen ion. And we have what? Numerous what? Hydroxide ion. Now, if you check the solution, you will find two kinds of what? Positive ion there, which are what? Calcium ions and what? And hydrogen ion. However, when you dissolve an acid in water, let's check. We have organic acid, we have inorganic acid, we are coming to that. However, okay, we have the ones that are popular. The most popular acids are HCl, HNO3, H2SO4, H2CO3, H2SO3, and then we have what? H3PO4. These are the what? The most common inorganic acid that we have. Okay. Now, if you look at all of them now, what is common to them? The fact that what? That the positive parts The positive part of all of them, they are what? Hydrogen. Do you understand? And that's why when we want to name the acid, we don't say hydrogen chloride. Okay? We want to name the acid itself. We call it what? Hydrochloric acid for this one. But every other one, we just call the what? The names of the what? Of the negative radicals. We just call the names of the negative radicals, and after calling them, we just put acid. That acid that we put shows that what? That they start with what? With H. So this one will be triazonitrate 5 acid. This will be what? Tetraoxosulfate 6 acid. This will be what? Triazocarbonate 4 acid. This will be what? Triazosulfate 4 acid. This will be what? Tetraoxophosphate 5 acid. That acid you put there shows that sort. It starts from what? From hydrogen. Though there are some compounds that are like, you can say, hydrogen triazonate 5. That is not the acid we are talking about. An acid is an acid if it contains water. There must be water before what? An acid will what? Become what? An acid. Do you understand? So when it contains water, we call this hydrochloric acid, of course. We call this triazonitrate 5 acid. We call this tetraoxosulfate 6 acid. We call this triazocarbonate 4 acid. We call this triazosulfate 4 acid. We call this tetraoxophosphate 5 acid. Are you getting it? Now, what happens when we dissolve this in water? What happens when we dissolve this in water? Remember what happens? If we dissolve this in water, water still contains what? H plus and what? And OH minus. But if we dissolve this in water, for example, okay, this will dissociate, right? Because water will weaken the bonds, right? This will not disassociate. Do you understand? We will have what? We now have what? H plus what? NO3 minus. Now look at it now. Look at what is happening here. By the time you dissolve it in water, from the acid will dissociate to what? To hydrogen ion and what? Triazonate 5 ion. The water still contains what? Hydrogen ion and what? And hydroxide ion. If you check inside that what? Inside that liquid, the only positive ion that you will find is what? Is hydrogen. Am I communicating? The only positive ion that you will find is hydrogen. So that is why we define an acid as what? As a substance that dissolves in water to produce hydrogen ion as the what? Only positive ion. Am I communicating? Do you understand? That is why we define it like that. An acid is what? Is a substance that will dissolve in water to produce hydrogen ion as the only positive ion. If you check others too, that is what happens. Because from the acid, the positive ion is what? It's hydrogen ion. In fact, a substance is acidic only when it can what? When it can produce what? Hydrogen ion in an aqueous solution. Okay? Others can, though, because water already contains what? Hydrogen ion. But from them, there is no what? Hydrogen ion from them. Are you getting it? Only an acid can produce hydrogen ion from his what? From his molecule. Are you getting it? Because why? Hydrogen is what? Is part, or hydrogen is what? Is the positive ion from it itself. Are you getting it? So that's why we define an acid as what? As a substance that dissolves in water to produce what? Hydrogen ion as the only positive ion. I hope you understand that. Now, when we're talking about acids, the types of acids, okay, the types of acids can be classified in. We can classify them into 3 different categories. We can classify them into 3 different categories. Okay. We have criteria we use to classify them, okay? We can classify acid, or we can state the types of acid due to their water contents, due to the water content of the acid, the water contents, okay? All right? We can classify an acid due to its water contents. We can also classify an acid due to its ionizing power. Its ionizing power, okay? All right? Or its dissociation power. Okay, ionizing power or dissociation power. Then we can also classify an acid due to its source. All right, those are the 3 categories we can classify an acid into. Okay, the water content, the ionizing power, and also what? The source. The water content, the ionizing power, and also the source. So the water contents, there are some acid that will contain more water molecules. The water molecules will be much more compared to the what? To the acid molecules. Are you getting it? Okay. The water molecule can be what? Can be much more than the what? Than the acid molecules. Are you getting it? Yes, sir. Now, when the amount of water molecules is much more than what? Than the amount of what? The acid molecules. We call that kind of acid a dilute acid. We call it what? A dilute acid. A dilute acid is an acid that contains more water than the acid molecules. That contains more water molecules than the acidic what? Molecules. I hope I'm communicating. Okay, that is what we call what? Dilute acid. Okay, a dilute acid is an acid that contains more what? More water molecules than what? Than the acid molecules. Now, when we call the other one now, will be the one that contains what? More acid molecules than what? Than the water molecule, right? So those ones, that one will be what? Will be called what? A concentrated acid. It's called what? A concentrated acid. Concentrated acid. Okay? An acid which contains what? Contains more acidic molecules than water. We call it what? A concentrated acid. Do you understand? So that's it. All right. Now, any of these molecules can be concentrated. Any of them can be what? Can be acidic. If practically, physically, okay, this HCl now contains more acid than water. We call that what? Concentrated hydrochloric acid. But when it contains more water molecules than acid molecules, we call it what? A dilute hydrochloric acid. Do you understand? So any of them can be acidic and dilute. Any of them can be concentrated. Do you understand? Now, the next kind of what? Molecules we have is the ionizing. Next criteria to classify an acid or to state which type of an acid we have. Well, in terms of their ionizing power. In terms of their ionizing power. Now, under this ionizing power, we have what we call the strong acid and the what? And the weak acid. We have the strong acid and the weak acid. The strong acid and the weak acid. Now, an acid is said to be strong if, when you dissolve it in water, all of the molecules of that acid will dissociate into hydrogen ion and chloride ion, and the negative ion of gas. Do you understand? If this H2SO4 is a strong acid, by the time it dissolves the acid in water, all the molecules of the acid you put in water, all the molecules, each and every one of them will dissociate to form what? Hydrogen ion and sulfate ion. All of them, no one will be left. All of them will dissociate. So you will not find any molecule that is in the form of H2SO4 again. What you just see is hydrogen ion, sulfate ion, and of course, because water is there, hydrogen ion and hydroxide ion. Do you understand? None of them will be left undissociated. None of them will be left unionized. Do you understand? That's what we mean by what? By a strong acid. It is strong. Why is it strong? Remember that what? That an acid is an acid only because it can produce hydrogen ion, right? So an acid in which when you dissolve water, all of them will dissociate. That means we have more what? More hydrogen ion, right? Produced, is it not? That will make it what? To have more acidic properties. Do you understand? Unlike a weak acid in which what? It ionizes partially in water. It dissociates partially in water. When it dissolves in water, only some of the what? Only some of the molecules of the acid will dissociate. The rest will still be left in the form of that acid. Like for example, H2SO3, or let me use H3PO4, is a weak acid. It's a weak acid. Because when you dissolve in water, not all the molecules of what? Of the H3PO4 will dissociate to what? To hydrogen ion and PO4 and 3-. Of course, some of them will dissociate, but not all of them. So some of them, you still find that some of them will be left undissociated. In that case, the number of hydrogen ion that is produced is less, right? That will make it to have less acidic properties. So it's a weak acid. Are you following? So a weak acid is one that ionizes partially in water, while a strong acid is one that ionizes completely in water. Are you following? Now, we have example of strong acid. Not all acid can be strong, of course. Not all acid can be weak. Some acid is strong, some acid is what? Is weak. Naturally, it is natural. There's nothing you can do about it. All right. So, out of these 7 most common acids that we have, okay, these 3 are the ones are the strongest. Okay, you understand? These ones are what we call strong acids. You understand? Strong acid. All right. While these 3 are the what? Are the weak acids. Okay. Okay. We have 7 of them. I have not mentioned one. H2CO3. Okay. We have HNO2. HNO2. Diazonitrate 3 acid. Okay. So there are 7 most popular. All right. So we have what? Hydrochloric acid as strong acid. We have 2095 acid as strong acid. We have tetraoxosulfate 6 acid as strong acid. Then we have the weak acid, tetraoxocarbonate 4 acid, tetraoxosulfate 4 acid, tetraoxophosphate 5 acid, and diazonitrate 3 acids. All these acids are what? They are acidic because why? They produce hydrogen in aqueous solution. However, okay, some ionize completely in water. Those ones are called strong acids, like hydrochloric acid, 95 acid, tetraoxosulfate 6 acid, and then the remaining ones are what? Are weak. Because why? When they dissolve in water, when you put them in water, okay, only some of their molecules will dissociate. That will produce less amount of water, less number of water hydrogen ions, which will show what? Less acidic properties. So they are weak acid. So the last one is what? Is the source. Is the source. Where is it obtained? Under this particular one, we have what? The organic acid. And then we have what? The inorganic acid. Now, organic acids are acids that can be produced in living systems. Okay, they have their source from what? From living things, like in plants and also in animals. Are you getting it? Those are organic acids. Okay, while inorganic acids are those ones that can be produced by simple chemical reaction. Okay, they are inorganic. They are produced outside living things. Okay, so it's from simple chemical reaction that occur. So organic acid, the examples of organic acid is we have the ethanoic acid, which of course, okay, let me put it somewhere else so it doesn't get confused. So we have what? Under organic acid, we have our ethanoic acid. Ethanoic acid find its source in ethanoic acid is found in ethanol, right? In ethanol, alcohol. Okay, ethanoic acid is found in what? In alcohol. Then we have citric acid. Citric acid found in what? In what? I think lime. Then we have ascorbic acid found in orange. Then we have lactic acid found in milk. All right. What again? Fatty acids found in what? Found in lipids, right? Fat and oil, right? Lipids. So on and so forth. These are examples of acids and where they are found. Then we have inorganic acids. These ones I just mentioned, they are all inorganic acids. I hope you understand. So it's as simple as that. That's not about what? The source of acids generally. The source of acids, okay? Now, before we go into the basic properties of acids, all right, we'll talk about how and what we call a basicity of an acid. Basicity of an acid. The basicity of an acid The basis of an acid is the number of replaceable hydrogen ion. Okay, is the number of replaceable hydrogen ion present in one molecule of an acid. The number of replaceable hydrogen ion present in one molecule of an acid. The number of replaceable hydrogen ion present in one molecule of an acid. All these molecules, they are one molecule of the acid. Okay? So when we talk about the number of replaceable hydrogen, how many hydrogen ions are there? Now, not just how many hydrogen ions, how many replaceable hydrogen ions? The question is, what do they mean when they say replaceable? Replaceable. I cannot explain the term replaceable hydrogen ion in an acid without talking about what? A salt. A salt. Now, look at all the acids here. Look at all the acids here. Look at all of them. Look at all of them. When you remove any of the hydrogen ion, any of the hydrogen, you remove them and replace them with what? With a metallic ion. You know metallic ion now? Those ions that positively charged ions, okay? Cations, okay? All right? And those are metallic ions, okay? All right? So if I remove any hydrogen ion here and replace any of these hydrogen ions with what? With a metallic ion, okay? Or ammonium ion. Ammonium ion behaves like a metallic ion because it has what? A positive charge. NH4 plus. This is ammonium ion. Okay? When I replace any of these hydrogen ion here with what? With a metallic ion. Metallic ion can be what? Na plus, can be K plus, can be Cu2 plus, can be Ca2 plus, can be Mg2 plus, it can be Al3 plus, okay? It can be Al3 plus, it can be Pb2 plus, it can be Pb2 plus, it can be Fe2 plus, it can be Fe3 plus, all right? These are examples of what? Of metallic ions, okay? When I just use when I pick any of these acids now, remove the hydrogen ion and replace the hydrogen ion with what? With a metallic ion or an ammonium ion. We have what? We have what? A salt. A salt. So the normal salt that we use to cook, the one we use in cooking, how is it formed? We pick hydrochloric acid, HCl, and replace this H here with a metallic ion. Which metallic ion? Sodium ion, okay? So when you replace it what? With NaCl, okay? Na plus Cl minus 1 plus multiply, when we have what? NaCl, all right? That is how what? Our normal sodium chloride is formed. The one we use in what? In cooking. So it's a salt, but it is one of what? Numerous salts that we have. Are you following? Are you following? So that is how it is. That is how it is. Okay? So when the hydrogen in an acid is what? Is replaced by what? By metallic ion or ammonium ion. We call that what? We call this compound that is formed, the resulting compound, we call it what? A salt. I can form more salts here. When, for example, Al replaces what? Hydrogen in this what? So when Al replaces maybe hydrogen in this one now, in trisulfate 4 acid, what is formed? What is formed? Okay, for example, we remove what? The H2, the 2H here, okay, from here, and replace what with aluminum ion. So we have Al3 plus, replacing hydrogen now. Now SO3 2 minus. So we are removing this H plus, and then what we are replacing it what with Al. Now the compound will not look the same because why? The ions of what? Hydrogen is not the same thing as the ion of what? Of aluminum. So you must use the ion of aluminum to what? To combine it what? With this what? Negative ion. Okay, since aluminum is replacing the hydrogen ion there. So what you have there is what? Is of course this 3, this 2. So when you have this, when you cross multiply, you now have what? Al2 SO3 in brackets what? 3. This is the salt that is formed. And how is it formed? By using what? Aluminum ion to replace what? To replace hydrogen in what? In trisulfate 4 acid. Am I communicating? And that is how what? That is how the salt is formed. So you see why we call what? Those hydrogen ions replaceable, because they can be replaced by metallic or ammonium ion. Like for example, if ammonium ion now replaces what? The hydrogen in what? In H2SO4 now, for example. we will have what we call, we have NH4 plus combined with SO42 minus, right? Since we have removed hydrogen, we are replacing the hydrogen with ammonium ion. So we have 1, 2. The ion of ammonium ion is what? 1. The ion of this is what? 2. So when you cross multiply, you have NH4 in bracket 2SO4. Okay? So this is what? Ammonium tetraoxosulfate 6. It's a salt because why? The hydrogen ion in what? Tetraoxosulfate 6 acid has been replaced by what? By an ammonium ion. Okay, that is why we call it what? We call it a salt. Am I communicating at all? And that is just it. That is just how it is. That is just how it is. So we call this hydrogen ion replaceable, but why? They can be replaced by what? By metallic ion or ammonium ion to form a what? A salt. So the number of hydrogen ion that can be replaced, the number of hydrogen ion that can be replaced in what? In an acid, okay, is what we call the basicity of an acid. Do you understand? For example, now, how many hydrogen ion can be replaced here? Now, we have what? 1, right? Okay, so the basicity of hydrochloric acid is 1. The basicity of hydrochloric acid is 1 because it has only one replaceable what? Hydrogen ion. Now, triazonitrate 5 ion, triazonitrate 5 acid, it has only one hydrogen in one molecule, okay? One molecule here was contain what? One hydrogen. So we say what? It has what? One replaceable hydrogen ion. So the basicity of triazonitrate 5 acid is what? Is 1. Are you getting it? Now, tetraoxosulfate 6 acid has what? Has 2 replaceable hydrogen ion in one molecule of the acid. So you say what? The basicity is what? Is 2. Okay, that of triazocarbonate 4 acid is what? 2. That of what? Triazosulfate 4 acid is what? 2. That of tetraoxophosphate 5 acid is 3. That of triazonitrate 3 acid is what? Is 1. If you look at their formulas, you can get what? The basicity of the acid. However, it is very, very possible that an acid can have more than a certain number of hydrogen ion. It is possible that an acid can have a certain number of hydrogen ion, yet not all those hydrogen ion will be replaceable. Some of them might not be replaceable. A chief example, a good example is ethanoic acid, which is CH3COOH. 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 Now, if you look at this, ethanoic acid has 4 hydrogen atoms in its molecule. 4 hydrogen atoms. However, not all these hydrogen atoms can be replaced by metallic ion. Why? Because when you dissolve ethanoic acid in water, it will dissociate in this way: CH3COO minus plus H plus. So only this H is an hydrogen ion. Do you understand? The others are part of the negative ion. Do you understand? Do you get it? So ethanoic acid is actually what? Monobasic. It has one basicity of 1. Take note that when the basicity is 1, we call that acid what? A monobasic acid. When the basicity is 2, we call that acid what? A dibasic acid. When the basicity is 3, we call that acid a tribasic acid. For example, tetraoxophosphate 5 acid is a tribasic acid, while tetraoxosulfate 6 acid is a dibasic acid. Tetraoxosulfate 6 acid is what? A dibasic acid. And what? And hydrochloric acid is what? Is a monobasic acid. So look at ethanoic acid now. Though it has what? 4 hydrogen atoms, only one is what? Is hydrogen ion. Okay. So therefore, it is a monobasic acid. Okay. It has a basicity of 1 because only this hydrogen will not be replaced can be replaced by what? By metallic or ammonium ion. Do you understand? It's as simple as that. It's as simple as that. All right. So that is not about what? The basicity of an acid. Okay. So let's go quickly. Let's go into the properties, the basic properties of an acid. The basic properties of an acid. All right. The physical properties. Okay. All right. Acids turns. That's the first thing. acid turns blue litmus paper to red. When I have a blue litmus paper and I put an acid, and I put it inside what? Into an acid. When I have a blue litmus paper and I put it into an acid, it will turn red. If I put a red litmus paper inside an acid, it will remain red. Okay, so the color of a litmus in an acidic solution is always red. Okay, you understand? So a blue litmus paper will turn what? Red when put in an acid. Okay, do you understand? So an acid turns what? A blue litmus paper red. Are you getting it? Now, another thing about acid is that what? Acid has what? Has sour taste. Has sour taste. Now, what's mean of sour taste? A shocking sensation in your mouth, in your tongue, on your teeth. Okay, a shocking sensation. By the time you put it in your mouth, it appears as if it is shocking you inside. Are you getting it? That is what we call what? A sour taste. And acid has a sour taste. In fact, it is the presence of what? Of acid in what? It is the presence of an acid in unripe fruits that make it has that shocking sensation, shocking taste. Okay, sour taste. Okay, so an acid has what? A sour taste. Acids generally, they have sour taste. Okay, the next one is that what? The concentrated form of an acid is what? Is corrosive. It can cause organic matter like the skin to burn, to get burnt. The concentrated form, the one that is concentrated, that is that have what? More acidic molecules than water molecules. Okay, they are what? They are corrosive. Do you understand? So that is that. All right, about that. Okay, those are the physical properties of an acid. Okay, an acid turns blue litmus paper to what? To red. An acid has a sour taste, and then the concentrated form of an acid, it is what? Corrosive. All right. Now, what about the chemical properties of what? Of an acid. Now, when we talk about chemical properties in chemistry, we are talking about how a compound or a substance would react with other substances. Its behavior, how it reacts with them, and what is formed. How it reacts with them and what is formed. That is what we call chemical what? Properties. All right. So the first thing we're talking about in acid is what? The reaction of what? With metals. How do acids react with metals? How do acids react with metals? When you add acids to metals, what happens? What happens when you add acids to metal? All right, it's very simple. An acid will react with metals that are higher than hydrogen in the electrochemical series or in the activity series to liberate hydrogen gas. An acid will react with what? With metals that are what? That are higher than hydrogen in the electrochemical series to liberate hydrogen gas. In other words, if that metal is not higher than hydrogen in the electrochemical series or in the activity series, when you add that metal to an acid, nothing happens. But when the metal is not higher than hydrogen in the electrochemical series, of course, when it enters into that compound, it's what? Hydrogen gas will be liberated. Now, why is this? Why is this? It's very simple. The activity series is an arrangement of what? Of elements in order of their reactivity. Okay? It's the arrangement of what? Elements in order of their what? In order of their reactivity. Am I making sense at all? All right? It is the what? It's the arrangement of elements in order of their reactivity. When you go to the activity series, it will look like this. Potassium will be first. Then we have what? Sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, then gold. This is this is just a summary of the activity series. So in this place now, you find out potassium is the most reactive earth metal. Like I said, then followed by sodium. Sodium is more reactive than what? Than calcium, but less reactive than what? Potassium. Okay, and that is how it is. All right. Zinc is less reactive than potassium, sodium, calcium, magnesium, and aluminium, but more reactive than iron, tin, lead, hydrogen, copper, mercury, silver, and gold. Now, if you look at all these series, these activity series, okay, if you look at this activity series, you will find out that what? That the most reactive substance are what? Up, and the less reactive substance are down. Like gold now, for example, gold is what? Is less reactive. All right, gold is less reactive. Is one of the what? Most unreactive what? Metals that we have. All right, the most unreactive metals that we have, gold. All right, that's why you don't see gold in compound. You cannot hear something like gold chloride, gold tetrasulfate 6. You can never hear something like that, because why? It is mostly unreactive. That's why it is found itself at the bottom. Now the rule is this: when I add a substance, okay, an element to a compound containing another element. Maybe when I add a metal to a compound containing another metal, all right, if that metal we're adding to that other one is more reactive than the one that is in that compound, okay, that metal that we're adding will displace that one that is in that compound. For example, if I add sodium to any compound at all, that contains zinc, what happens is that what? Sodium will displace zinc. That's what we call displacement reaction. Sodium will displace zinc from that compound. Now, what is the meaning of what? Of displacement. What is the meaning of displacement? Sodium will displace zinc in the sense that sodium will remove zinc from that compound and stay there. For example, now, if I add sodium is what? Na. If I add sodium to what? To ZnCl2, sorry, because zinc is what? 2 plus. Okay, zinc is 2 plus, Cl minus, because multiply, you have this. Okay, so if I add sodium to what? To zinc chloride, what will happen is that what? Sodium will displace zinc. Why? Sodium is more reactive than zinc. Being more reactive than zinc, or having more reactive power than zinc, what will happen is that what? Sodium will remove zinc from there and stay there. So what we now have is what? NaCl. Why is it NaCl? Because of the ionic balance, right, of sodium and chlorine. This is 1:1. So if you cross multiply, the valency of sodium here is what? 1. The valency of what? Chlorine here is what? 1. So when you cross multiply, you have what? NaCl. Because 1, you don't normally write 1 to get this. So it's NaCl. So it's what? NaCl plus chlorine will now what? Will now be displaced, right? Chlorine was Cl2. Now, I'm sorry, it will be what? Zinc will now what? Will now be alone here. So we'll now have what? Zn. Okay? So this is what? Solid. This is aqueous. Of course, this will be aqueous, and this is what? Solid. Now, how does this occur practically? When we add sodium to what? To a solution of what? Zinc chloride. We find out that the sodium will start what? Dissolving in the what? In the zinc chloride what? Solution. After some time, it will be dissolving. As it will be dissolving, after some time, we'll now start seeing what? Solids of what? Of zinc that will start forming. Do you understand? That is sodium pushing zinc out of the what? Solution and staying there. Am I communicating? And zinc is now what? Is now alone. Are you getting it? Do you understand? So that's what we call displacement reaction. However, when we what? Add zinc to what? to a solution of what? Sodium chloride. Nothing happens. Nothing happens. Nothing happens. Because it is not possible for what? For a less reactive substance to what? To displace a more reactive substance from a solution of its what? Salt. Am I communicating? Or from a compound that contains it? Do you understand? And that is why all these elements, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, we always displace hydrogen from any solution that contains hydrogen. Am I communicating? That is why when we come to acid, in acid, remember that what? An acid is a substance that produces hydrogen ion as the only what? As the only positive ion. So the positive ion in an acid is what? Is hydrogen ion. So because of the fact that it is present in the activity series, when you react a more reactive what? Element with what? With a compound that contains hydrogen, of course, hydrogen what? Will be displaced. Do you understand? Hydrogen will be what? Will be displaced. Hydrogen what? Will be displaced. Do you understand? And then that is how hydrogen gas is formed. Because why? The hydrogen will be removed, and what? And the element what? Will stay there. Do you understand? So, but only this can only happen when what? When the element, when the metal is higher than hydrogen in the activity series. I hope you understand that. So if we react what? Potassium with what? With HCl. What happens is that what? Potassium what? Will displace what? Hydrogen, right? To form what? KCl, right? Plus hydrogen gas. Now, this hydrogen gas, these 2 years because of the atomicity of what? Hydrogen. Hydrogen is diatomic, okay? That's why we have what? 2 years. So if we have to balance, potassium is 1 year, potassium is 1 year. Balanced, hydrogen is 1 year, hydrogen is what? 2 years. So to make hydrogen balance, we put 2 years, okay? Do you understand? Now that the hydrogen is now what? 2, hydrogen is now 2, balanced. Now chlorine is what? Is 2 years. When we put any number here, the number is going to affect everything here. So hydrogen, chlorine is what? 2 years. Chlorine is what? Is 1 year, right? So to make chlorine balance, we have to put 2 years, okay? All right. When we put 2 years, chlorine is now balanced. However, potassium is already what? Affected, okay? So our potassium is 1 year. So what do we do to make potassium balance? We put 2 years, okay? And that is that about that. So it's a simple thing. It's that simple. When I add what? Calcium, for example, to what? To H3PO4. When I add calcium to H3PO4, what will happen is that what? Calcium being higher than hydrogen in the electrochemical series will displace what? Hydrogen from what? From the acid, okay? To form what? Ca. If you do the ionic balance, calcium is 2 plus, this is PO4 3 minus. So you cross multiply 2 and 3, okay? The 3 will come to calcium, while the 2 will go to what? PO4. So we have what? Ca3PO4 in bracket what? 2, right? Then plus what? Hydrogen gas, okay? Hydrogen gas will be what? Will be liberated. So calcium is 3 here. Put 3 here to make calcium balance. Alright, hydrogen is what? 3 here, but 2 here. So what I do is what? I put 2 here and put 3 here. Are you getting it? If I put 2 here, 2 times 3 is what? 6. Are you there? And this is what? 2 times 3 is 6, 2. Is it not? Balance. Now, potassium is 2 here. This bracket makes this 2 to affect both of them here, right? So potassium is 2 here too, right? Now, oxygen is what? 2 times 4, 8 here. Oxygen is what? 2 times 4, 8 here. It's balanced. Am I communicating at all? And that is how it is. That is how it is. That is how it is. Do you understand? Do you understand? So when you add hydrogen, when you add any substance, metal that is higher than hydrogen in the electrochemical series to what? To acid, it will displace hydrogen from what? From the acid. Actually, even water contains, the positive part of our water is what? Is H plus. Water contains H plus and OH minus. So when you add water, when you add hydrogen, an element that is higher than hydrogen in the electrochemical series, when you add it to what? To water, okay, it will still replace hydrogen and form hydroxide, because what will be left is what? Is OH, right? So it will form an hydrogen of the metal. For example, when I react with sodium with what? With water, okay, it will form what? NaOH, right? Plus what? H2 gas. Okay, so that is how it is. That is how it is. So that is the what? First what? Chemical properties of what? Of an acid. Okay. Now the now the second one, the second property of an acid is what? Reaction between what? An acid and a base. The reaction between an acid and a base. Reaction between an acid and a base. Now, acids generally react with what? With bases. Okay, all right, to form salt and water. The process is very simple. It's called neutralization reaction. Neutralization reaction is what? Kind of reaction in which what? An acid reacts what? With a base to form salt and water. An acid reacts with a base to form salt and water. It's as simple as that. Okay, so a base, of course, a base are oxides and hydroxides of metals. Bases, they are oxides and what? And hydroxides of what? Of metals. Oxides and hydroxides of metals. Okay, the metals, we have 5 of them that normally form bases. Okay, we have 5 metals, which are what? Potassium, K, sodium, Na, magnesium, Mg, calcium, Ca, and aluminium. Okay, all right. These are the 5 substances that can form what? Bases. Are you getting it? Are you getting it? Okay. So the oxides of these metals, as well as their hydroxides, they are bases. Okay. So the oxides will be what? O2 minus, right? You combine it with O2 minus, right? So if I combine this K plus, right? And this O2 minus. K plus in the sense that potassium is losing 1 electrode, right? So K plus O2 minus, all right? K plus O2 minus, all right? This is 1, 2, right? When you close multiply, you have what? K2O, right? This is potassium oxide, it's a base, all right? If we combine, sodium is still changing Na plus Na plus what? O2 minus, right? So you have what? 1, 2, cross multiply, you have what? Na2O1, right? So it's Na2O, right? This sodium oxide is a base. Are you getting it? All right? If you combine this, Mg2 plus, right? And O2 minus, this is 2, 2, right? 2 here 1, 2 here 1, right? So if you do that, you have what? MgO, right? Is a base. Do you understand? Is a base. Calcium, since if you do it, to give us CaO, calcium oxide, is a base. Okay? If you add Al to O3, this one gives Al2 because Al is what? 3 plus. This is O2 minus, right? 3, 2. You cross multiply. If you have Al2O3, aluminum oxide, also a base. So the base, all these substances, they are what? Their oxides are bases. Also, their hydroxides are also what? Bases. Hydroxide is what? OH minus, right? Is what? OH minus. OH minus. So when you combine this OH minus with any of the metals, you have what? A base. Okay. So oxide and hydroxide of metals are what? Are bases. Like what? If you add it to what? To any, this is Na plus, right? OH minus 1, 1, right? That's why it's form what? NaOH. Sodium hydroxide. Are you there? Do you understand? Now, when you combine this, if you combine it with potassium, you have KH, right? That is potassium hydroxide. Okay, a base. Do you understand? Then, if you combine with calcium, you have what? Because calcium is say what? 2 plus, right? It will give you what? CaOH in brackets what? 2. All right. If you do that, the same thing to magnesium, it's got MgOH in brackets 2. If you do the same thing to aluminum, it's got aluminium OH in brackets 3. Right? So it's as simple as that. These are what? Bases. All right? These are bases. Now, when you react any of the base with what? With acids, okay? What will be formed is what? Is water. Salt and water. Salt and water in the sense that the salt will be formed because why? The metal in what? In the hydroxide or the oxide. We now go and replace the hydrogen in the acid. Are you getting it? Do you understand? And remember that a salt is formed when what? When the hydrogen ion in an acid is being replaced by what? By metallic or ammonium ion. So when I react, for example, if I react what? H to, okay, let me use HNO3 plus any of the base. Which one? Let's use CaO, right? What will be formed is that what? Calcium will go here and replace what hydrogen here, right? While the hydrogen will now come here and replace what? The calcium that left here. Do you understand? So we now have something like, when the calcium replaces here, we now have what? CaNO3 in bracket 2. Why is NO3 in bracket 2? Because NO3 is what? NO3 minus. And Ca is what? 2 plus. So if you cross multiply, you have what? CaNO3 in bracket 2 plus, now the H now. The H now that will come here, okay, will now combine with what? H and O, right? H plus O2 minus, right? So 1, 2, if you cross multiply, you have what? H2O, right? To form what? H2O. This is salt, this is water. Are you there? Do you understand? So that is what forms salt and water. This is what we call what? Neutralization reaction. Am I communicating at all? It's as simple as that. Okay? It's as simple as that. Okay? So if I react, how is our NaCl formed? Very simple. It is what? NaOH that combines with what? With HCl, right? When this happens, what happens? The Na will come here and replace hydrogen here, right? To form what? NaCl. Now the H will not combine with what? OH, right? To form what? H2O. OH is 2H and 1 O, right? H2O. Do you understand? So it forms what? Sodium hydroxide and what? Sodium chloride and water. Salt and water. So just pick any of the words, acid at all. Reactive is what? With any of the base. The same thing happens. Are you getting it? The same thing happens. Alright? If H2SO4, for example, combine with an alkali, okay, with a base, let's say MgOH in bracket 2, for example. What is formed here is what? Magnesium will go and replace hydrogen here, right? We now have what? MgSO4. Are you getting it? MgSO4, right? Plus what? Plus what? H will, the H that left here, okay? Alright? We now combine with this OH to form what? H2O. So that is how it is. Alright? Alright? So when an acid reacts with what? The base, one salt and water. That is why some people will define an acid as a substance that reacts with the base to form salt and water. Are you getting it? That's another definition of an acid. Okay? It's a substance that will neutralize the base to form salt and water. Because here, this reaction is called what? Neutralization. Okay? Do you understand? The base is what? Is basic. The acid is acidic. So they neutralize each other to form a neutral solution. The neutral is supposed to be what? Salt and water. But not all cases that will provide, that will see, that will give what? Salt and water. That one is that. That one is about that. Alright? The third and the last property of acid is, the last property of an acid is reaction with what? With triazocarbonate 4. Reaction with triazocarbonate 4. Like I always tell my students that triazocarbonate 4, most compounds are identified by their negative radical, by a negative substance. Like sodium chloride, they will tell you sodium chloride is a chloride. It's a chloride. If I say Na2S, this is a sulfide. Sodium sulfide. It is a sulfide. Are you following? Are you following? It is a sulfide. As simple as that. Alright? So triazocarbonate 4 are those substances that what their negative radical or their negative ion is what? CO3 2 minus. Are you getting it? Do you understand? Those are what? Triazocarbonate 4. Like CaCO3 is a triazocarbonate 4. Calcium triazocarbonate 4. Known to many as what? Limestone or marble chip. Calcium triazocarbonate 4. MgCO3 is also what? The triazocarbonate 4. How is it How does it arrive at this kind of what formula? Ca2 plus CO3, 2 minus, right? 2, 2, 2 here 1, 2 here 1. It will give what? CaCO3. Calcium Charles vitamin 4. Do you understand? Alright, so when you cross multiply, the same thing happens here. If it is sodium, because sodium is 1 and CO3 2 minus is 2. 1 and 2 cross multiply, you have what? Na2CO3. All these are Charles vitamin 4. K2CO3. Okay? Aluminum does not have a what? A Charles vitamin 4. The Charles vitamin 4 of aluminum does not exist. It doesn't exist. Alright? So that is it. So when an acid reacts with what? With a Charles vitamin 4, 3 products are formed. 3 products are formed. This is a rule in chemistry. And it's a very important rule. When you react an acid with what? With a Charles vitamin 4, there are 3 products. Number 1, carbon 4 oxide. Carbon 4 oxide will be formed. Okay, number 1, carbon 4 oxide will be formed. That is by nature. Yes, it's true. Carbon 4 oxide will be formed. Number 2, water will be formed. Water H2O will be formed. Okay, water will be formed. And then number 3, the salt of the corresponding metal. The salt of the corresponding metal. The corresponding metal here is what? Calcium. The corresponding metal here is magnesium. The corresponding metal here is what? Sodium. The corresponding metal here is what? Potassium. The salt of the corresponding metal will be formed. That is, the salt that is formed when the metal replaces hydrogen in the acid. Am I communicating? That is what will be what? That is what will be formed. Let's try it now. For example, when we react HCl, for example, when we react HCl with let me say CaCO3, what will happen is that what? Carbon 4 oxide is formed. Are you getting it? Water is formed. Okay? Then the salt of the corresponding metal, that is the salt that is formed when the metal here replaces what? The hydrogen here. Are you getting it? So we have what? CaCl2, right? This is what is formed. Okay? This is what? An example of reaction. Okay? Between an acid and all you just have to know is what are the 2 reactants. If one of them is an acid and the other one is a Charles vitamin 4 of a metal, just follow this rule. Carbon 4 oxide, water, and the salt of the corresponding metal. Okay? In this case, what? Calcium chloride. If, for example, now Na2CO3 is reacting with maybe H2SO4, of course, because this is a Charles vitamin 4 and this is an acid, the rule comes to play. Carbon 4 oxide, water will be formed. Then the salt of the corresponding metal. What will be the salt of the corresponding metal? To be Na2SO4. Why? Because Na plus SO4 2 minus, right? So it will be what? Na2SO4. And that is that. That is the properties of what? Of an acid. Okay? I'll stop here because our time is fast spent. In our next class, we are going to be doing the preparation of acid. Okay, how the various methods by which acids can be prepared. Okay, and that is the last thing we'll talk about acid. Then we'll move over to what? To base and what? And salt. All right. Thank you very much, and God bless you.